Thank you very much, everyone, and good afternoon or evening. My name is Mofesola Babalola. I am an infrastructure engineer. I live and work out of Berlin in Germany, and we flew all the way from Berlin here. And interestingly, we have another talk today tomorrow about Istio in Zurich. So once we're done with this, we'll go to the airport and fly out to make sure we catch that talk. We're very excited to be here to share some of our knowledge with you about what we've been doing at work. A little bit about me. I picked up skiing of recent, so it's an addiction at this point. I hope I have enough money to follow that addiction. When I'm not skiing, I'm cycling, I'm roller skating, and yeah, that's about me. Over to you, Hannah.
Okay, thanks for coming to our talk. I guess it's around afternoon and not many people are awake still, but thank you for making time. My name is Hannah Olukoye, living in Berlin as well. I've been living there for 3 years. My second time in New York, and yeah, I pretty much know my way around now. So a bit about me, well, I would say my journey into tech has been really interesting. I started off as a web designer, web developer, and then I transitioned over to DevOps, so I was a deployment engineer. And then I really went deep into mobile engineering for building for Android. And so right now I'm working as an engineering manager because yeah, I'm really passionate about helping tech teams, other software engineers really grow and thrive in their role. So I work for a different company, Mofesola works for a different company in Germany, but we thought to bring this topic together because we have different perspectives and we can share that today. In my hobbies, I like to bicycle, ride around here. So yeah, we can start off. So we prepared a short agenda just so that you can understand the flow of our talk today. The first topic, of course, is we're giving you some context about what are some of the problems that SREs are actually struggling with in their teams, and then what is the actual solution of zero trust, like how does it come in, why is it even important? Then we introduce to you Istio, something that Mofesola has already set up within the team. And then we give a short case study on how exactly this works, and then we round off with key takeaways. Our favorite part of giving a talk is the questions that we get to receive from you because we get to learn from all of you. So please feel free to ask questions, and yeah, we can make this session really interactive. Okay, so I'll give it over to Mofe.
All right, so this is a very interesting topic for me, and I know that many people have this problem with security. You build out something and you know it's working, and then you have a security team tell you something is broken because it's not secure enough. And we've always tried to figure out how to make things secure without stretching ourselves. There's this typical problem, the castle and moat problem, wherein you secure the perimeter, but then inside the perimeter everything is free. I come originally from Nigeria before I moved to Germany, and the kind of systems that we had there was kind of like different. So you get to the house, from the house to go into my dad's bedroom, there's a door in the corridor, and then it's locked, and then my dad's bedroom is locked, and then the wardrobes are locked, and then it has a safe inside that's also locked. The fridges are locked, the pantry is locked, the toilets are locked. So moving to Europe was kind of like a paradigm shift for me. People enter the house and all the doors don't even have locks, Maybe only the toilets have locks. And the kind of concept that we have when it comes to security, when it comes to zero trust is people can enter into an environment, but then it doesn't mean that you should trust them to enter into your sub-environment. And we're going to show exactly how Istio helps to solve this problem. Okay, so, I've talked about this in passing, but I will talk about it more in technical terms. So most people have like a load balancer, like typical architecture. You have a load balancer, you encrypt traffic hitting the load balancer, you terminate TLS at the load balancer, and everything behind the load balancer within the VPC, within your Kubernetes cluster is unencrypted traffic, so it's plain text, and anybody that finds some way into your environment can just move laterally without being questioned. Nobody expects that the identity is fraudulent, or we pretend not to expect that the identity is fraudulent once they find their way into your environment.
We forgot one more thing.
Yeah.
To ask in the room, how many have used Istio or set it up so that we give, okay, it's
Okay,
really good to know,
Yeah.
so that we're not talking something abstract that it's really nice.
Okay, cool.
So, yeah.
Yeah, so I will introduce Istio for those who don't know Istio. So Istio started as a CNCF project a couple of years ago, and it has really matured now. 2 days ago I set up, or I upgraded many of our clusters to the most recent version, 130, 102, not sure now. And of course, we've been running the ambient mesh for a couple of years now. But there is a problem that Istio has promised to solve. And I'll be very brief about this because I've had problems like talking to my colleagues about, is this new level of complexity actually necessary? You know, Kubernetes is very complex. You have etcd, you have kubelets, you have kubeproxy, you have DNS, kubedns. You have all of that. You have worker nodes, you have the control plane, you have different CRDs, you have operators. And while people are still trying to grasp how services and ingress and pods and replica sets and daemon sets and all of these things work, you say, hey, that's not enough problem. We need to introduce a service mesh. And my argument is this. I always tell people this. If you get to the complexity where you need a service mesh, one of two things is likely to happen. You either build a service mesh, a poorly designed one, inadvertently, or you implement a proper service mesh. And we're going to talk about like different things that the service mesh does, especially in relation to security. And I'm also going to explain some more things about the ambient mesh.
Yeah, I think something about Istio as well is for when a team is trying to sell this case to stakeholders, to other team leads, what would be the selling point for it? Because someone will think, okay, Istio is open source. How secure is it?
Yeah, I mean, Istio is generally secure from my experience, and because of the intro. So we'll talk about 3 pillars and talk about exactly how security works with Istio. Initially, we had like the sidecars, you know, it's still being deployed with sidecars, and then it moved on to the ambient mesh, which also created more security, helped to improve latency, and helped to also distribute the apps in such a way that if you don't need certain features, you can offload them or decide to scale different parts of Istio independently. So like, instead of scaling the Envoy proxy with each of your pods, you can decide to use the Waypoint proxy, point your different apps to it. And I will talk about like the 3 pillars, right? The verifiable identity, the verifiable authentication, and the explicit authorization. But before I go into that, there's something I always would ask Hannah about, like the relationship between security and user experience, which I would still talk about how it still comes to play later on.
Yeah, so the general idea is when you have user experience and you want to compare it to your security, you're like, one has to overweigh the other, right? So every time you're thinking, oh, this thing has to be really secure, the user ends up suffering. But if you're thinking, oh, I want the user to have a seamless experience with my application or my service, the security gets a lower priority. So think of an example of using Apple Pay. You want to tap and go, you want to pay your payments, just like tap and go on your phone. But the easier it is to do that, the more vulnerable it is, right? So someone can walk around the room with a payment, POS, and just walk around the room, get money out of all our pockets. But at the same time, Apple has thought it through. Okay, we want this person to make sure the device, the owner of the device has tapped maybe their facial recognition or their fingerprint. But I think with Istio, I'm really curious to hear how exactly does this work?
Yeah, so thank you for that. One thing that Istio does is this. Like she mentioned, there is an inverse relationship between security and user experience. You beef up one, it looks like you're putting down the other. One of the things I found out about like implementing Istio is this. While it's still relatively true, right, the problem is just in the initial phases. So setting up Istio, setting up the configuration, if I would have to do this manually or think about it the way you explained using Apple Pay, then it's going to be tedious. But when Istio takes all of that off your neck, like things like mutual TLS, things like request authentication, request authorization, you do the painstaking work, painstaking in quotes, work of configuring all of these things in the start, and then you enjoy the benefits for a long time to come. Yeah, let's move on.
Yeah. So the first pillar on identity.
Yeah, so verifiable identity. So most of the time, I mean, in times past when I was using Istio with sidecar proxies that had to be injected with the, what's it called now? With the admission controllers in Kubernetes, you have a situation wherein if Istio is supposed to be deployed in a pod that's scaling, you need to like inject the Envoy proxy into the pod. And that meant that for you to run Istio, every pod, whether they needed layer 7 kind of services or not, you would need to run the Envoy proxy. But then, with verifiable identity and the ambient mesh, you could actually deploy Istio. So you have Istio CNI, which is a daemon set. You have zTunnel, which is a daemon set. And you can keep it at that. And then by that, you can have security, MTLS security, zero trust security, out of the box without like doing too much configuration. Of course, you can set that up like with this, 7 lines of code, and then you have MTLS out of the box.
Okay, so we go to the second pillar on verifiable authentication.
Yeah, so this is where the ambient mesh now proves some problem to people, especially because with zTunnel is a Rust-based eBPF application, works on layer 4, and you need something that can process traffic on layer 7, and you need the waypoint proxy, or previously with the sidecars, you have Envoy proxies running within the entire cluster. So you need something like JWT. How many people know what JWT is? For show of hands. Okay, cool. Many of us, I used to write PHP some 15 years ago. To implement this, you need like boilerplates or classes, and you do this and integrate a lot of things. Okay, they made it easier for different languages. So if I have 5 different language stacks within my environment, I need to implement JWT for each of these apps. It still says you don't have to do that. You can offload that problem to infra, and it still sits in front of your application and says, hey, we're going to check if you're authenticated, if this works properly, and you don't have to like write boilerplate into every of your application. You can control that on the infra layer.
Yeah, I think you actually faced a really big challenge with one of the teams setting this up. That was a bit, yeah.
Yeah,
about it.
Yeah, I mean, there was, of course, we had problems like this. That was something really different, but it's a nice knowledge to share. I remember we were setting up like JSON web tokens, and we're trying to like debug what was happening. We had like 2 servers that had different time protocols, and they had like a time shift difference. And it was very difficult for us to see and x-ray into what was going on, because the request, a JWT gets generated, but has a different time from the client, from the server. And so all the requests were failing, and it was very difficult for us to find out what was happening. This would have easily solved a problem like that.
Yeah, okay. So the last pillar, explicit authorization.
Yeah, so this one is actually very interesting because, you know, I know many people understand what least privilege access is, and this actually helps us to narrow down things. So you're saying, if service A doesn't need to talk to service B, I need to explicitly say, you don't have to talk to this. And it's also something that I'm implementing now, not even on the side of Istio at work. We use EKS, so we're doing EKS pod identities. Before we had like nodes that had, you know, Godfather roles just to make sure that everybody's safe and easy. But now we are making sure that each pod can have their identity and have only permissions that are needed. It's the same thing that you want to implement with Istio. If the request service doesn't need to talk to the transaction service, there's no reason why that pathway is open. If that pathway is going to be open, we need to be explicit about it and say, hey, we need request service to talk to this service, or we need these services in this namespace to talk to services in this namespace. And this is what that problem also solves.
Okay. So I think now we can go a bit deeper into the case study and be a bit more technical, and then we'll still refer to the 3 pillars that we mentioned. So in this scenario, we give some context about what we're trying to explain.
Yeah. So, you know, one interesting thing about security is that it's that uncomfortable guy in the room. I was a software engineer. I just want to write my code and get things working, you know. Okay, while I'm writing my code, I want to do like basic sane stuff. I have a framework that does maybe checking SQL injection for me, cross-site request forgery, all the, the known things. Someone comes and says that, oh, I need to make sure that every service within my cluster authenticates to themselves. It's just completely tedious. Let's face facts, right? And we never expect that these problems will happen. Indeed, many of us never get to be called to the problems I've had to deal with in production is something is not scaling up, this thing is at 100% CPU, there's some logs problem here. Only very few times have I had to deal with security problems in production. But when they happen, they could be very catastrophic. And I would walk you through the kind of problem you could have in this situation and how Istio also helps to prevent this. So you have an application, and then someone does remote code execution within the application. We talked about the different pillars, right? So previously, without the ambient mesh, with the Envoy proxy, if someone has access to the Envoy proxy of your application, they could get the identities out and pretend to be that guy and then execute code on your behalf or exfiltrate data and things like that. But now, with implementing all the pillars that we've mentioned, you could get to a point wherein someone exfiltrates data and your PEMs, your CASATs and everything and pretends to be you. So they pretend to be this application, but then while they have the identity, they are making the call from the wrong place. You have an authorization pillar that's put in place and then the request fails. Or they try to make a request within the cluster and they have not verified the identity, client to server, server to client. With MTLS, the request also fails. With the ambient mesh, it's even more secure because the identity of these services are not stored in the sidecar proxy because there is no sidecar proxy. The identities are stored in memory space of zTunnel, which is a node-level daemon set. You don't have access to it. So even if an attacker has access to your pod, it doesn't have access to the daemon set, doesn't have access to the memory space. So yeah, most of those kinds of attacks would fail because you've implemented a tool like Istio.
Okay. I guess.
Yeah, so I talked about I talked about this already. Okay, so we've talked about verification and policy enforcement. So this is exactly how it works. You can run through all of this. I talked about stealing identity. So the spiffy identity can be stolen in the sidecar proxy deployment. With the ambient mesh, you can't do this because it doesn't even exist to you. And then Istio helps you evaluate all these matches. You said this service can only talk to this service, this namespace can only talk to this namespace, and then it evaluates all of that. And then it rejects when it doesn't work.
Yeah. So I think for in that case, the security is really tied up really well.
Yeah.
But what happens, if something gets wrong?
Yeah, so people ask this question every time, yeah, you've implemented security, it looks good. We blocked this service, we did this authorization thing. What if everything aligns? Yeah. What if the attacker is calling from the right namespace, calling the right service, has exfiltrated the right credentials, and the call just looks legitimate? And this is what I tell people. You can keep improving security, like we talked about earlier, but then you're going to affect user experience, and you need to find out exactly how to balance these two things. How much can I improve user experience or security in such a way that I do not affect user experience? What's more important in this environment, user experience or security? And I always talk about this in relation to what one of my professors told me back in college. He asked us in class one day, he says, what's the most secure system in the world? Who has the answer to that? Who knows what it is? The most secure system in the world, yes? Sorry? No, I mean computer system.
Which computer system is
the most secure in the world? Yeah? Okay.
Pull the cable.
Sorry?
Pull the cable over.
Yeah, okay, fair. What else wants to answer?
Both of you?
Okay. Yeah, so he said something very similar to what you said. He said the most secure computer in the world is one that is staying in a bunker in Fort Knox, completely guarded by soldiers day and night, has no internet access. Now I'm adding my own, no AI access, and is permanently switched off, right? So the point is, when you start to run a computer, when you start to add agentic models, when you start to connect it to the internet, give access to human beings, then there is always that chance that you are going to have problems with security. So the whole idea is not building a system that's 100% foolproof. If you want to build that system, then you need to follow what I said. Put it in Fort Knox in a bunker, no AI access, no internet access, so just 247 and permanently switched off. Otherwise, then you have to know that you're dealing with risks.
Yeah, so what I'm hearing as a technical lead, as an engineering manager, is there's so many payoffs by using Istio. First of all, the velocity. I like that you don't have to write millions of lines of code. Mm-hmm. There's only a really simple way to have a config file sitting in one place that you can keep referring to. And I like that. There's reliability as well. So you're presenting all these failures that wake you up at 3 a.m. On-call duty is now much simpler, which is a win for my team exactly. Security, which we've been trying to sell right now on Zero Trust, which is, there's a breach, the prevention breach from containment, and our services are now more secure. Then the last one, which is observability. I know we've gone through a few stands out here that are really trying to sell on this observability, and Istio already comes with that. So I really like that we have this all four covered.
Yep.
So the last point is on the key takeaways that we leave this talk with. At least if you didn't listen to anything that Mofe said, in the end, you need to ask yourself in your team, is a mesh really right for us right now? Are we running only maybe 2 services and we're thinking, oh, let's go into Istio? Like, does it make sense for us? Then when you start to actually imagine yourself setting up Istio, start small by installing ambient mesh, of course, and just observe. In the beginning, just observe how it goes. Don't set it up on everything and then wonder why things are crashing. And then the next step is, of course, to move over to the critical services and then again observe. Then the last point, of course, is to deploy a weapon proxy for everything. And this way you're making sure that your Istio setup is set up really well. I know some teams really struggle with this because in the initial step of setting up Istio, they really did it not really well. Mm-hmm. But do you have any tips on how they can reverse that somehow? Or do they need to start again from?
So, I mean, like if you set up Istio, so first things first, I know the struggle point for many organizations is not, whether they've set up Istio poorly or not. The initial point is, do we need to set up Istio? And that's what you talked about, like in evaluating, right? And a lot of teams still struggle. Do we need to put this extra layer of complexity? Mm-hmm. We have complexity everywhere. I've dealt with teams before where instead of writing like virtual services and destination rules that are easy for everybody to read, they've gone into Nginx and written like proxy lines and Lua scripts to, proxy this request to this request and do like a lot of layer 7 routing. But if you've done that or you've deployed Istio wrongly, you can actually set up things properly and start to like move things over little by little. If you have like layer 7 configs that you've used some manual tools to do, or nobody knows exactly what's happening, you can manually start to shift those over to Istio little by little, and then you iterate and expand.
Yeah, okay, then that's good. There's hope for all those teams that have been struggling with this. And lastly, we just want to thank you for coming to our talk. Please give us some feedback by scanning the code. And right now it's time for questions, if you have any. Yeah, we're really looking forward to that. Thanks. Any questions? You can use the microphone. So
what are the protocols today that's supported by ambient mode? HTTP, of course. I don't know, how about databases? Or, I don't know, so you Kafka, or is there anything else than HTTP?
So you can pretty much route any layer 7 protocol through Istio, right? gRPC, it's one of its strong suits. gRPC is HTTP2, so you can pretty much route anything on layer 7, anything that communicates on layer 7, especially with the HTTP protocol. HTTP2, once it does that and does it really well, you can layer Istio right there.
Okay.
All right, any other questions? Or should I ask mine? Any other questions?
I thought someone had a question there.
Okay, yeah.
Hello. So how did you manage the complexity of adding multiple Istio rules? Let's say you are restricting service A from reaching service B certain endpoints. And how is that complexity going for, let's say you have 1,000 repo, multiple services and teams getting a tile handling those new policies being added every time they made some code changes?
Thank you very much for that question. Yeah. So, I mean, this is one of the things that Istio claims to solve, and I've seen it solve it real time. One of the things I did, right, to make life easier for developers is to actually write a Helm chart that's functional, right? So I have a Helm chart that does like all the virtual services, destination rules in patterns that are very meaningful to our teams. And I have proper documentation for that. If you want service A to not talk to service B, 3 lines of code referencing the Helm chart, and it's good. You don't have to learn the virtual services and all the special rules and everything. Everything is embedded in Helm charts, but for most people, 1, 2, 3 lines talk about like the service, the port number, the endpoints, and the Helm chart generates like the complexity behind it, which is abstracted from developer. And of course, we scale this into like many apps. If you've written 1,000 microservices, then you should be ready to write like 1,000 different 3 lines of code. I don't think that's too complex. But also something I'm noticing now, again, like fashion, tech is like fashion. 10, 20 years ago, it was like monoliths, mono repos everywhere. And then some 10, 15 years ago, it's now like microservices. If you're not doing microservices, you're doing it wrong. Now I see people reverting again.
Yeah.
You know, we need to learn to find like the sweet spot or the midpoint between those things. We don't need to swing between like one extreme to the other. I see people now like packing. I've worked with companies that have like 1,700 reports for like 3 or 4 products, you know, and like 600 microservices, and you have like this humongous cascading failures that you have to deal with without even agents that can predict what's going on. So yeah, if you have that problem, yeah, Istio is right for you to solve that problem. Okay, any other questions? Okay.
Oh, hello. Thank you for a great talk.
Thank you.
I am currently leading a project at my employer to migrate from Envoy sidecars to Istio ambient mesh. And so in the first pillar, the verifiable identity, I've already started to, I guess, do some deployments of Istio in dev, and I can see the MTLS traffic. What additional benefits would I gain from using the peer authentication? Because it seems without it, I'm already getting MTLS and verifiable identity, so what added benefits?
What added benefits do you get from using what?
From the peer authentication CRD
Peer,
that you mentioned.
peer authentication.
Yeah.
So like, you already have, so Istio ambient mesh, once you set it up, right, it has 2 modes when it comes to peer authentication, right? So you have strict, right, and you have permissive, right? So when you have permissive, what happens is that it makes the request and scales up it upgrades the connection security. So if the client cannot respond with MTLS, it downgrades and it's fine. It allows traffic to go through. If you set the peer authentication to strict, and then upgrades the connection, and client says, hey, I can't speak MTLS to you, the connection fails, your traffic breaks. And this is what we also talked about in the previous slide where we talked about like actions to take. You know, you don't have to like go like strict peer authentication immediately. You can go permissive. You go into Kiali dashboard. I don't know if you use Kiali to visualize your mesh. It's actually beautiful. You should try using Kiali. And you can see how traffic flows. You can see like the small padlocks there that shows that the traffic is MTLS encrypted and traffic goes through HBone. And if you do that, then you can see which traffic connections are going to fail if you upgrade, you know, the connection because they can't use MTLS, and make sure that everything is properly in the mesh before you enforce strict peer authentication.
That makes sense. So I think like by now I'm in permissive by default.
Yes, you're on permissive by default. Yeah. So you set, exactly. So you set that for the entire mesh. You go like peer authentication strict. You can also do it per service, per pod, per namespace, or you can make it as a part of the Istio system configuration for the entire mesh.
Thank you.
You're welcome.
Sorry, one last question.
Okay.
If I am running Istio, if I want to use Argo rollouts for manage the deployment, there is no issue for deployment because I know you can manage the deployments on Istio.
Yeah, so there's absolutely no issue. And it's interesting. I'll try to see if there is something like this on the web. I've actually gone through the painstaking thing of like deploying Istio with Argo CD and with Flux CD. And if there is nothing like that, I will probably just release something that's easy for people to deploy, because we have the Helm charts, but people exactly don't know how to tie these things together, especially because they are parts of, how Argo operates. They are parts of Istio that mutates as soon as you've deployed. So Argo tries to roll that back to match with what Git is saying, but then the cluster is saying, hey, this has changed, or I've generated a new CA-SAT, so like, then there's that fight. I've done deployments that have blocked out parts that I don't want Argo to manage, parts that I know only Istio is going to manage, parts I know that Kubernetes control plane is going to manage. So yeah, you can roll that out, and that's the best way to actually manage this in production. Use the Helm charts that are provided at source, and put those in your config, and make sure that they're properly configured and deployed to your cluster. And that's how we do it also.
Okay.
All right.
Yeah,
No
thank you,
other
Anna.
questions?
Thank you, Mofesola.
Yeah.
That was an insightful session.
Thank you so
you.
much.